Hello, Year 9 Science. Mr. Silva here talking to you today about kinetic and potential energy. This video is a short one. It's basically a review of what we've done this week. We talk about different types of energy. You had some reading to do. So I'm very pleased with your effort and with your tenacity, okay, to tackle concepts you haven't covered before. So you remember that the law of conservation of energy states that similarly to the law of conservation of mass, that no energy the energy cannot be created, it cannot be destroyed. This is a vital concept in science as a rule. So let's have a look at what we learn in kinetic energy. So that's the formula over there. Kinetic energy is half times mv squared. Believe me, this formula will come back at year 10, 11, 12 university. If you do something that is science related, this formula will come back to you, okay? And we've done many exercises in class. Most of you did really well. The average is above 70%, which is I'm very pleased with. Just a reminder, if you still don't remember what you have to do, let's do an example here, okay? First, let's understand this formula. So the kinetic energy there, let's change the color here. I'm going for red if you don't mind. So that's the kinetic stands KE stands for kinetic energy. Is half the mass of any object times its velocity squared. Okay, so this is profound because we're saying here that the energy stored in a body when it moves, it's related to its half of its mass times its velocity squared. This is quite amazing, in my opinion. Quite amazing. Okay, so M stands for mass, V for velocity, and that's kinetic energy, and the units, you know, they are in joules. Okay, so let's change the color here. I have an example for you. So we have an object that is the mass is roughly 10 kilograms. It's moving, its velocity is 10 meters per second. Okay, and we want to know what's its kinetic energy. That's simple one, I guess. So you write down the formula. Please show your work, okay? Write down the formula to demonstrate to me that you know what you're doing. So the kinetic energy in there is half times 10 kilograms times 10 meters per second squared. Okay, so the kinetic energy in there, what I would do is I would multiply this guy here first. Okay, so step by step, 10 kilograms equals to 100. Then you can multiply the other two factors there. Half times, so that will be 10 times 100. You know that this is 1000 there. So to finalize, the kinetic energy in that case will be half times 1000. Okay, so in this case here you could do the first operation. You could do 1000 divided by 2. That's option A. Or you could do 1000 times 0.5. That's option B there. Or you could do it's up to you, times a half. That's option C. All those options will give you the very same answer, which is 500 joules. 500 joules. Okay, so I clearly remember your faces when I first showed you this formula and how to work this out. You guys were terrified. Some of you were terrified. But now, I had some of you telling me yesterday, Friday, this is easier than balancing chemical equations. So you please me with that, because you are demonstrating that you're really having a go when I give you those challenges. Okay, so remember that in physics, always remember, in physics or on science, things are impossible when you start doing them. They're hard, they're impossible. and then they become trivial. They become trivial when you practice. Okay, I know that the analogies we make in class with the joules, you know what a joule is now. You understand that you have, if we talk, remember the apple, lifting up the apple from the ground 1 meter vertically up. There you go. You have to repeat that operation 500 times. Or you could do lift the apple 250 times and drop the apple 250 times to be able to use that amount of energy there. Now, I'm very pleased that you understand that. Okay, very, very, very pleased. So now let's go to the next type of energy. Okay, now we're talking about potential energy, okay, which is the energy of rest. Energy of rest. So when you're sitting like me now in a chair, you have potential energy, okay, because you're at rest. So it's also a very simple formula. So potential energy is equals to the mass of an object in kilograms times its acceleration of gravity. So remember that the acceleration of gravity on Earth is 9.8 meters per second square. Okay, and the height above surface in meters. Okay, so this here is important. 9.8 is on Earth. I hope you remember the extension exercise we did yesterday in class. You managed to get to that 9.8 number, which is how we calculate the acceleration of gravity on Earth. Please, the G number, have that in mind. Okay, so another simple example that if you don't remember how to do, if you're stuck, you don't know how to do that one, you should start with let's start with a very simple example. So we have an object. The object has a mass of 10 kilograms. You might be asking, well, why does he use 10? Well, 10 it's a good one to start. Okay, G on Earth, you know that is 9.8 meters per second squared, and I'm placing that mass. Imagine that this is a box. Okay, that's a box in there, and a cube, okay, or cube or a box, and that box has 10 kilograms. And then what you're doing is you are placing these at the very top of a pole, and the height here is equals to 10 meters. The height is equals to 10 meters. So you lift that box all the way to 10 meters and you leave it there. Okay, so that's the height, 10 meters. So to calculate the potential energy, you have to use the formula. Potential energy is equals to mass GH. So please do not calculate all the numbers at once. Your calculator will give you the wrong number. Okay, that's how you should be writing. 10 kilograms, 9.8 meters per second squared times 10 meters. Then you can start playing with the numbers. Okay, first thing what I always do is calculate those two guys here first. That's no secret. This will be equals to 98 times 10. So the potential energy there is equals to 9,800 joules. However, I really encourage you to be writing like this: 9.8 kilojoules, because remember this is 9.8 kilojoules, or even better, 9.8 times 10 to the 3 joules. So doing this calculation here for the potential energy is quite easy. Okay, it's quite easy, but for the moment that you start writing 9.8 kilojoules, you understand that this is it's nearly 10,000 joules. Okay, and when you write 9.8 times 10 to the 3 joules, you are using scientific notation. Okay, so this is a science class, and we want you to I want to get used to write scientific notations, because imagine if that number was something like 9 joules, that will get messy, really messy. Okay, so what you would do is 1, 2, 3, 4, 5, 6, 7. That looks like a caterpillar. So 9.8 times 10 to the 7 joules. I would say, whoa, that's that's many units of joules in there. Okay, so I hope this example makes sense. There are many examples on the internet. The formulas are very simple, guys. You should be able to do that if you try. Please have a go. Please have a go.